Just a second. Okay, we are live now. Zulfa, you can start.
Thank you, Mohammed, and welcome everyone to the final presentation of the Clean Energy for Africa Volunteers Program. So this program has been an extensive training for 3 months by the volunteers and professional instructors to provide the training and general information to the volunteers about the renewable energy of Africa. So today we are going to listen to the final presentations by the volunteers, starting by Jennifer and then Matthew, and then we will end up with Faisal. So all the 3 volunteers have been in the program since 3 months, and we are going to learn from them about the journey they took through this program, what they learned, and they will share with us some feedbacks about this program. So before starting, I would like to talk about the Clean Energy for Africa. For those who don't know the group, it's a platform by young engineers dedicated themselves to support the renewable energy in Africa. We are providing updated research, resources, and webinars. So we are quite active in the region and in the field of Africa's clean energy. And we are focusing through this program in the studying of cases related to the continent. As we know, Africa is the second largest continent in the world, and it's the fast growing continent when we come to the resources, the renewable energy field. So for that, we hope this program can add to the clean energy for Africa, and we hope that you will enjoy the presentations today. So I would like now to hand over to our first presenter, Jennifer from Kenya. She will be talking about the integration of renewable energy sources for the sustainable rural development in Kenya. So please, Jennifer, you can start your presentation. Jennifer, if you started talking because we cannot hear you, please be sure that your mic is open.
Okay. Thank you, everyone. Good evening and welcome to this presentation. My name is Jennifer Mbide and I'm from Kenya. And I will be sharing my topic on integration of renewable energy sources for sustainable rural development in Kenya. I've been in the program for the 3 months and my instructor has been Dr. Azir from Sudan. So just to start my presentation, I'm going to introduce myself. I'm born in Kenya and born and raised in Kenya. Currently, I'm an MSc student doing energy engineering at the Pan-African University Institute for Water and Energy Sciences in Algeria. And I recently presented my thesis on optimizing and techno-economic feasibility of a hybrid energy system for rural electrification. My background is in manufacturing engineering and technology, and I graduated in 2015. Have worked in CMC Motors Limited in the engineering division as an intern, and I'm a certified graduate engineer by Engineers Board of Kenya. So the presentation of my outline will be looking at the general overview of the energy and then look at the country background, that is the energy overview of my country, that is Kenya. Then I look at renewable energy resources potential in Kenya. Then look at the energy efficiency measures, the programs that are in place in order to increase the energy efficiency. And then I look at energy access rates in rural areas. And finally, look at integration of renewable energy for sustainable development in rural areas. Sustainable energy provision has a strong interrelationship with socioeconomic advancement of any country. Energy is critical, and most of the daily activities will not be achieved without provision of energy. Now, for sustainable, for social development and for economic development of any country, together with technology advancement, this is not possible without provision of sustainable energy. And over the years, technology improvement and population growth has dramatically increased the energy demand. Now, this energy will keep on increasing as long as there is technology advancement and population growth. Now, in order to match this increasing energy demand with supply, the world has looked into improving the energy supply from renewable energy resources in order to ensure the security of supply amidst fears of diminishing fossil fuels. Now, why look into renewable energy resources? This is because of their reliability in power supply and minimal environmental pollution compared to fossil fuels. And with this, there has been massive attention towards renewable energy resources because of their abundance and clean environment. Now, Africa is blessed with the abundance of natural resources, especially solar. In fact, it is estimated that solar alone can meet the energy demand of the entire world. But despite these resources, there are more than 600 million people in Africa who have no access to electricity and 900 million lacking access to clean cooking. According to International Energy Agency, that is in 2009, they suggested that roughly 80% of people without electricity access are from rural areas in sub-Saharan Africa. And 90% of this population in rural areas depend on firewood for cooking and heating and kerosene for lighting. And from the pictures, we can see raw biomass. We can see people cooking with raw biomass, which is inefficient, and children learning using kerosene, which is harmful to their health. Now, when we come to Kenya's energy background overview, we can see that Kenyan government has worked to improve its utilities through the Ministry of Energy and Petroleum. And in order to attain its Vision 2030, which is to convert Kenya into a middle earning state and provide exceptional residing standards for its people, and in order also to achieve the big four agendas, which are manufacturing, universal healthcare, modern housing and food, modern, clean, reliable, and affordable energy is required. Now, in attaining this Vision 2030 and Big Four agendas, we will not only be meeting the SDG 7, but also we will achieve SDG 1, SDG 2, and SDG 3. Kenya has made tremendous achievement in scaling up electricity connectivity rates with 32% in 2014, and currently in 2017 having 75%. This is both from grid and off-grid options. Currently, Kenya has a national installed capacity of 2,818 megawatts, and most of this is from geothermal and hydro. Now, when we look at the energy resource potential of Kenya, Kenya has a vast energy resources comprising of geothermal, solar, wind, and biomass. Now, when we start with looking at solar energy, due to its geographical location, Kenya receives relatively 5 to 7 peak sunshine hours and an average of daily solar installation of 4 to 6 kilowatt hour. The total potential for PV installation is estimated to be 23 terawatt hour per year. This solar energy is mostly utilized in lighting, mostly in rural areas where the grid is not, grid connection is not available. It's also used in drying, also used in water heating, that is in solar water heaters and solar water pumping, and also in microgrid systems. Now, if we look at the existing solar energy projects, we have the Garissa Solar Power Plant. This solar power plant consists of about 200,000 solar panels and covers an area of 210 acres. Currently, it provides electricity to about 625 homes. Then we have the Strathmore University 600 kilowatt rooftop PV solar power project. Now, the electricity from this solar power plant is used in the university, and the excess is fed into the grid. When we look at solar home systems, Kenya has quite a number of solar power distributors, which include Mkopa, Mobisol, Flexi Energy, and Sun Transfer. These solar power distributors, they sell solar power home systems to Kenya and also in the neighboring countries, that is Uganda and Tanzania. They sell these appliances at a flexible micropayment terms. And when, for example, when we look at Mkopa solar home system, this power distributor has managed to supply more than 300,000 units of solar power home systems. And the benefit of these solar power home systems, it has enabled millions of off-grid homes to replace the use of kerosene lanterns and also diesel generators with a higher quality and clean solar solution. Not only is it clean, but also it is cheap and affordable to mostly people living in rural areas. Now, we have seen the huge potential of solar energy in Kenya, but there are some barriers that prevent exploitation of this solar energy, and one of them is for solar power plants. It requires an extensive chunk of land required. For example, we have seen the Garissa solar power plant. It requires it has about more than 200,000 solar panels. And when we look at this solar farm requires quite a huge land, and therefore, if the land to put up this solar farm is community owned, you find that it is quite difficult to bring these people to agree on the sizing and compensation of this land. Now, when we look at wind energy, Kenya has quite a huge potential for wind power exploitation, and the potential for wind generation in Kenya is is with a total of 346 watt-hour per meter, with the main wind areas having an average of wind speeds of 9 meters at 50 meters. And these areas are in Marsabit and Turkana, which is the northern part of Kenya. But generally, the average wind speeds of Kenya are 6 meters and above. Now, the wind energy share is 361 megawatts, which is about 12% of its installed capacity. Now, just to look at the existing wind energy projects, we have the Lake Turkana wind farm and the Ngong Hills wind farm. And these two contribute the 336 megawatts. Lake Turkana wind farm consists of 365 wind turbines, each of capacity having 850 kilowatts. And it is the land in which it occupies is about 40,000 hectares. Now, with this huge potential of solar power, the barrier which prevents exploitation of the wind energy is lack of proper infrastructure for power transmission to load centers. This is because most of these wind farms are located in rural farms, and you find that building of infrastructure for transmission of this power to load centers is quite expensive. Now we're looking at hydro energy. The potential for hydro energy power production in Kenya is between 3,000 and 600 megawatts. This is from small microgrids and also mini microgrids. This is unexploited, but the currently capacity of hydropower potential installed capacity of the current hydropower is 28%, which is about 826 megawatts. And the government, through the Ministry of Energy, has identified between 50 kilowatts and 70 kilowatts capacity sites in order to increase the rural area power, in order to provide power to rural areas. Now, when it comes to barriers, which are barriers to implementation of renewable energy, not implementation of hydropower, we find that fluctuations of weather, fluctuations due to changing weather and climatic conditions affects exploitation of hydropower. And then we also have high capital intensive for plant construction and implementation, because most of this construction of these dams involves a compensation of movement, relocation of people from these areas in order to build this dam. And this is high capital intensive. Now, when we look at geothermal, it is presently the most promising renewable energy with a potential of 200 megawatts in Rift Valley, and it accounts for 45% of the installed capacity. The reason why the Ministry of Energy is looking at geothermal, it is because it is environmentally clean, immune to adverse effect of climate change, and it has also the highest capacity. But now the main limitation to geothermal is that it is site specific, and it incurs high upfront costs involved in drilling and construction of the plant. Now, looking at biomass, and here we are going to look at the raw biomass. Just like any other African country, especially in sub-Saharan Africa, woody biomass contributes to over 70% of the total energy demand and caters to nearly 90% of rural energy. That is firewood, mostly in rural areas, and charcoal in urban and rural areas for cooking. According to International Energy Agency, about 15% of the population have access to clean cooking. This is as of 2018, and the country targets to have 26% by 2030. The cooking devices, which are the 3 stone fires used by the majority of households in rural areas, have very poor thermal efficiency and serious health effects. And this is due to unclean combustion of the biomass. Now, rapidly growing demand for woody biomass, coupled with degrading forest resources in Kenya, calls for alternative and innovative solutions, policies, and technologies in order to reduce the effect of use of biomass. Now, when we look at
Jennifer, sorry to interrupt, but we have about 2 minutes to wrap this presentation, and we will have to be on time. So please try to finish in 2 minutes. Thank you.
Okay. Now, when we look at biogas, there are policies that have been instituted by the energy sector, and these policies include energy policy of 2004 and the Kenyan biogas program. And this promotes domestic and institutional biogas technology. And it is estimated that there are more than 20,000 biodigesters in Kenya as of 2019. These systems provide clean energy for cooking and also provide fertilizer to people in rural areas. Now, we also have briquettes. These are made from sugarcane waste, rice husk, and these offer alternative fuel, which is environmentally clean and We also have cogeneration. This is from sugar factories, and currently it accounts for 28% in the stored capacity. Now, when we look at the energy measures and programs in place, in Kenya, the amount of wasted primary energy input is 10 to 30%, and this is quite huge, and therefore the energy efficiency and conservation measures have been overemphasized. And some of the programs and measures in place in order to increase energy efficiency, increase the Energy Act bill. We have the Center for Energy Efficiency and Conservation Measures and Center for Energy Efficiency and Conservation. And this center conducts energy efficiency and conservation programs in order to help companies identify energy waste, determine saving potential, and give recommendation to in order to improve energy efficiency. Now, we also have our standards and labeling program, whose work is to ensure high efficiency in products in order to reduce cost investment in energy and also reduce greenhouse gas emissions. This is majorly in equipment and appliances. But still, with all these measures, there are still challenges which hinder implementation of the energy efficiency. And these include inadequate information to people regarding the methods and benefits of energy efficiency. We also have insufficient professional capacity to train people on energy efficiency measures. Now, when it comes to energy access rates, currently Kenya has a 75% access rate, and it targets 100% access rate by 2022. And this will be done through rural and off-grid electrification. Now, when we look at rural electrification, the rates are at 6.7%, and the country targets to increase this rate to 40% by 2024. This will be done through grid extension and rural electrification projects. Now, the institute that is mandated with rural electrification programs is the Rural Electrification and Renewable Energy Corporation, and this institute focuses on expansion of PV mini-grids, retrofitting, and hybridizing of existing powered mini-grids. And currently, we have about 27 mini-grids, and out of this, majority of them are run on diesel, which makes it have a high cost of operation, and also one of the limitation is intermittent nature of the renewable energy resources. Now, in order to solve this problem, integrating different renewable resources is an effective method. This will reduce cost of operation as well as the intermittent nature of the renewable energies. Now, how do we integrate the renewable energy sources for sustainable development? One is to increase access to efficient energy for domestic use, and the other solution is to increase access to electricity. How do we increase domestic efficiency in domestic use? This is done by use of improved cooking solutions. And some of these improved cooking solutions include use of pellets and briquettes instead of charcoal and cook stoves. We can also use biogas and improved cooking stoves. Now, this is an example of improved cook stoves, and we can see use of biogas for cooking. These improved cooking solutions will reduce demand of wood fuel, decrease household air pollution, which is from use of raw biomass, and also improve the lives of women and children in rural areas. This is because women and children are the people who look for wood for cooking, and also are the ones who are involved in collection and cooking of this wood. So it affects their lives, and using of improved cooking solution will improve their lives as well as their health. Provision of clean and affordable energy. This will be provided by use of biogas lamps for lighting. We can also use solar home systems. These can be single solar home systems as well as hybrid renewable systems. From this picture, we can see use of biogas for lighting, and we can see use of single solar PV panel for home use. And also we can see use of hybrid PV wind system for rural electrification. Now, once we integrate the renewable energy resources in rural development, Then there are benefits that comes with the integration. And some of these benefits are social benefits. We will have improved health and well-being, especially for women and children. We will have improved access to information. People can use electricity to watch TVs and listen to news. We will have improved learning conditions and performance. We will also have improved security from using security lights. And some of the economic benefits include job creation, flourishing of small businesses. This is because people will extend their opening and closing of their businesses. We will have access to cheaper electricity. We will also have diversification of income sources. People can have different sources of income, such as farming and small businesses. And some of the environmental benefits will be reduced deforestation and charcoal burning. We will also reduce the emission of greenhouse gases because we are using clean energy sources. Now, in conclusion, we have seen that renewable energy sources have important role to play in reducing energy poverty, especially by increasing the energy efficiency access and also electricity access in rural areas. Now, different energy sources, depending on resource potential in the region, can be integrated effectively. This is to supply energy needs of rural areas in Kenya. We can use solar, we can use wind, depending on the resource potential in that region. Increased efforts to provide improved cooking solution can significantly generate income, improve livelihoods, and also save fuel costs. Provision of clean, modern, and affordable electricity from solar and other hybrid can eliminate energy poverty in rural areas, and integration of renewable energy resources for sustainable development in rural areas as both socioeconomic and environmental benefits. And these will improve the livelihoods of people in rural areas. These are some of the references that I've used. And thank you.
Thank you, Jennifer. Thank you. You have been a very great value to the Clean Energy for Africa Volunteers Program. And thank you for the very informative presentation. And I would like to share with everyone that Jennifer have recently defended her thesis. So congratulations, Jennifer, and great thanks for presenting this presentation. And we hope that the program has been of a benefit for you in the renewable energy field in the continent of Africa. So for this, we would like to move from the research track to the professional track by presenting, the presentation will be by Matthews. Please, Matthews, prepare yourself. So Matthew from Malawi will be presenting about investigating Malawi's renewable energy potential. So please, Matthew, you can start your presentation.
Zulfa, I think Matthew said he had some technical issues, so maybe we could start with Faisal instead, because I see that he's not, he still hasn't been able to rejoin us, I mean.
Yes, I see he's not in the participants. So then at this point, we will have to move to Faisal. Please, Faisal, prepare yourself. So Faisal from Sudan will be presenting about the assessment of the Darfur solar electrification project. So Faisal actually is a senior mechanical engineer at the University of Sudan. Please, Faisal, you may start your presentation. So until Faisal set himself, we would like to speak about the tracks as part of the Clean Energy for Africa Volunteers program. So as we introduced at the beginning, the program is a 3 months extensive training program in the renewable energy field of the continent of Africa. And we have 2 tracks. The first track is the research track, which Jennifer has been part of. And in this track, she will be, or she had been exposed to different cases related to the renewable energy field of Africa. As she presented, it was part of the solar energy, of the biomass, of hydro energy. So it was different kinds of renewable energy in the continent of Africa. And then the other track is the professional track, which will focus on the market, on the business, on different practical sides of the renewable energy field. So I hope that will give you a good information about the program. And if Faisal is ready, you may start your presentation.
Hello everyone. I was trying to share my screen, but I couldn't.
Can you retry again, Faisal? Because I made you co-host. There should be a button, green color button, share screen.
Can you see something now?
No, nothing, not yet. When you click the share screen, you can choose like desktop, so we can see the full screen.
I guess I have a problem. I have an error.
Okay, Faisal, it's no problem. I can share your presentation because I have it. So
Okay.
I'll share for you, and then you can present.
Okay.
All right, everyone can see the presentation now.
Yes, Mohammed.
Okay, Faisal, you can start.
Yes, yes, we see.
Okay, so my name is Faisal Mustafa. I'll be presenting today about a title called Assessment of Darfur Solar Electrification Project. This article was instructed by Dr. Muhammad Al-Haj. So when we talk about the Darfur, before we start the presentation, I want to just present myself. My name is Faisal Mustafa. I am 23 years old. I'm still studying undergraduate mechanical engineering at University of Khartoum. Actually, I'm very passionate about renewable energy, and I'm planning to have my graduation project and my master's degree in renewable energy. Now I'm volunteering with the Institution of Mechanical Engineering, which is an organization dedicated to provide sessions and workshops for students. I'm also volunteering with SCADA, which stands for Sudanese Childhood Diabetes Association. I'm also a volunteer with the International Youth Sudan organization. So to start my presentation, I will first start with the map of Darfur. I will give a brief introduction about Darfur and the states and the wars. I will then move to the project and its outputs. Then I will state the numbers and types of the solar systems installed in this project. Then I will be talking about the challenges and the recommendation based on the previous previous projects. Then I will speak about the budget, and at the end, I will speak about the capacity building and the socio-economic impacts of this project. So to start, I will describe the map of Sudan. As we can see here from the map, Darfur is located in the west part of Sudan with more than 8.7 million population. Actually, the Darfur region contains five states. The states are north state, south state, the east, west, and the central states. As we can see from the figure, the North Darfur and the South Darfur are the biggest states among the five. Next slide. So this is a brief introduction about the states and population. As we know, as most of you know, Darfur has been a conflict zone for almost 2 decades. The war has started in 2003, and this war has left more than 2.5 million of internal displaced people, and over 200,000 people died from as a consequence of it. The factors attributed to this war, one of the factors actually, because there are many other factors I don't want to talk about, but as related to my subject here, I would talk about the resources. And I mean by resources here, resources such as land and clean water and the food. So this war resulted in a biggest food shortage, and many citizens, as I mentioned, have been displaced, and the electricity access rate was less than 2% of the total electricity generated in Sudan. Actually, this also has led to the livestock, high shortage in the livestock, and underutilization of the resources, such as we know that Sudan in general has a large potential on solar and on renewable energy in general. Like for example, we have a high radiation rate in Sudan, and we have many areas that have a great potential for wind energy, and we have like for example a gold in Darfur that is not mined yet or have been mined. Next slide. The energy sector in Darfur. So one important information that we should know about Darfur is that most of its energy is generated by thermal power plants, which is actually less than 70 megawatt through thermal power plants. When we speak about the solar or the renewable energy, actually it has been introduced recently, and there was a project, or there were many projects on such, for example, solar cookers and solar systems. But recently, I guess two months before 2 months or 1 month, they were implemented 5 megawatt power plant in Al-Fashil. Actually, one of the impacts of this is it would result in a fuel saving of 3,000 tons of fuel, which is a large share. And actually, many programs such as this would lead to would alleviate or mitigate the tension created by the war. So to speak about the project itself, actually this project is not the 5 megawatt of that implemented in Al-Fashil. This is a separate project. So the main project here, it's called the Darfur Solar Electrification Project. It's implemented on the outcomes of Doha Agreement for Peace, which is signed in 2011 between the government of Sudan and the DRA, which stands for Darfur Regional Authority. So the main output of this project was to install solar systems in 7 villages. In the next slides, I will be speaking about these solar systems. But for now, I will just go over it. Dr. Muhammad, please repeat fast. Yes. This project has been implemented in partnership with many organizations such as UNDP and UNIDO, WHO and UN Habitat, and MWRA stands for Ministry of Water Resources and Electricity, and NARC stands for National Energy Research Center in Sudan, and the DRA, which stands for Darfur Regional Authority. The total fund of this project was estimated at $5.6 million, and it's shared by UNDP 95%, and the UNIDO has shared by 5% of the total fund. Next slide. So I guess there is one missing slide that talks about the outputs of the program. Yes. So I will be speaking about the outputs of the program. Then I will come to the budget. So the main output, as I said, was to install solar systems in 70 villages, which is about 8,120 solar systems for community services. The output was to provide technical assistance, and I mean by technical assistance, to provide knowledge for the people of Darfur in order to maintain and to install their systems themselves. The third output was to establish microfinancing policies, which is really important for the development of the renewable energy sector in the world. The fourth output was to raise public knowledge, and raising public knowledge will be through programming to initiate a website in the media and to publish many research on renewable energy, and to one of the main part of output 4 was to publish an atlas for Darfur. It must be published for all the renewable energy potentials in Darfur. So I guess it will be a great benefit for the people who would like to invest in this sector in the future. So now I will be going to the budget to speak about the. We know the 4 outputs of the program. So output 4 was the output 4 was 80% of the total budget, which accounts for around $5 or $4 million. As we can see here from this figure, output 2, output 3 in the left, and output 4 has given a lower percentage, and I guess less than 10% was given to the rest 3 outputs, which is I guess not a good point for the project, because the project, as we know, aims for the sustainability, and we need to, as output 2 states, we need to develop the knowledge of the people and the capacity of them, and we need to initiate microfinancing through the banks. So those are all important points that need to be considered and then given a lot of money. So the GMS here stands for the indirect cost, and we can see that the operational cost estimates are total budget. So now we are going to speak about the management board. So the board is a board that created just to coordinate between the, as we know, there are many organizations here, just to coordinate between these organizations. I will just speak about the main roles The first one is the senior beneficiaries in the left. From its name, senior beneficiaries is all the individuals or the groups that representing the interest of people of Darfur. In short, they are the people who will benefit from this project. Peoples or organizations. Peoples are clear, the people of Darfur. For the organizations, I mean here the Ministry of Water Resources and Electricity and the National Energy Research Center. The executive is the person who runs or who chairs the group. And here it can be represented by the UNDP, because as we know, the UNDP has the biggest share in this project. The senior supplier are the people or the groups who supply, who give or who supply the group either with fund or with knowledge. With fund, as I mentioned, the UNDP and the UNIDO. With knowledge, the National Energy Research Center, for example. So the project manager is going to run the meetings and run the tasks on daily basis and so on. The last two in the photo are the energy specialist, which is responsible for the technical parts of the project, and the monitoring and evaluation officer, which is responsible for the documentations and evaluations and monitoring reports. So this is a brief introduction about the management board. Please, Dr. Muhammad, move to the next slide. So now I will be speaking about the systems to be installed in each state, as we know from output one. So there are 48 systems that must be installed for schools and 14 for health centers. For police stations, there are 14 systems. Note that these systems are to be installed in each state of the 5 states. So the women development sectors, 14 systems, and solar pumps are 14 systems. The total was 1,624 systems. When I multiplied it by 5, the total number will be 8,120. That's the total systems to be installed. I will come later to the socio-economic impacts that is related to this, the implementing of schools or new health centers or police stations and solar pumps. So next slide. The direct beneficiaries of this project are estimated at 35,000, and the indirect beneficiaries are 150,000 people. The direct beneficiaries are clear, the people who will benefit directly from this, from the installation of these systems. The indirect beneficiaries are the people who will benefit indirectly, such as the manufacturers, the suppliers of the materials, and marketing jobs, the people who will work in trade in the market, and so on. Next slide. So now I will be talking about the capacity building of the program, as stated in output 2. So as an output, a solar training manual is published, and it is dedicated to technicians to develop the capacity for technicians. This manual contains how to measure the radiations and measuring devices, such as how to measure the voltage and the current, and by what devices you measure them, and the PV concept. I mean by that how the solar radiation is transferred to electricity. And at the last section, the manual speaks about the batteries, types of batteries, the installation, how to install them, the sizing, how to size a specific system, such for solar or for lighting or for the normal use in the house, and the maintenance of such systems. In the next slide, I will be speaking about the socio-economic impact. What I mean by the socio-economic impact is the impacts resulting from in the social or economical or environmental sector. Actually, the speak about the socio-economic impacts would extend for days or weeks. So I will limit my speech here for just what is related to my article. So I will speak about the macroeconomic effects, which contain the GDP, which stands for the gross domestic product. What is gross domestic product? It's a measure of the overall performance of economy. So installing or deploying solar or renewable energy technologies would result in a huge effect in the gross domestic product for the country. Actually, the GDP can also be defined as the measure of the market value of all the final goods the country possesses in a specific time. So when we speak about the welfare, and the welfare here can be divided into two sections, like for example, to reduce the pressure on the ecosystems, such as reducing CO2 and the impacts on the human health. These two parts are the welfare parts, and the employment creation, the social deploying renewable energy technologies would result in a huge effect in the employment sector. It creates direct jobs or indirect jobs or induced jobs. The direct jobs are it's clear, I guess, the direct, I mean, by in the installation or the sizing process or the maintenance jobs. The indirect jobs are, I said earlier, are the jobs in the manufacturing of solar PV or wind, as example, wind blades or this. The induced jobs are the jobs that created in other sectors. So the jobs can be created in the following segments. In the planning process, jobs can be created in the manufacturing and the installations. And when you want to connect renewable energy power plant to a grid, you will create jobs in this sector, and the operation and maintenance, and the last one is the decommissioning. Actually, the operating and maintenance cost is the only one that is considered as a fixed jobs, but the rest are considered temporary, because when the planning stage ends, there is no other jobs for the planning sector, and so on the rest of them. So this is basically about the socio-economic in general. Now, how to measure in Darfur, the socio-economic in Darfur. Actually, this project will result in more jobs, as I said, and new schools and hospitals will be constructed, as I said earlier, in the systems to be installed. According to the schools and hospitals, many jobs will be created as teachers or nurses or doctors. Also, installing solar pumps would result in a clean water, either used for drinking or for irrigation for water for plants. This is also will result in the CO2 reduction, because we know that the fuel used for cooking and for lighting will be reduced, because we install solar systems for lighting, and there are also other projects for cooking. Actually, the war in Darfur has led people to use the trees for their need, like an alternative source. This has resulted in a highest rate of deforestation. So implementing this project will reduce the deforestation rate. And this will also result in the return of the internal displaced people. that I talked about them earlier, because such project will encourage and motivate people to return to their homes. This regards Darfur. So the next slide, I will be speaking about the tools for measuring the socio-economic impact. Actually, there are many tools that can be used for measuring the socio-economic impacts, like, for example, the GDP and the CO2 reduction and how many jobs are available. The most famous are the E3ME and the JEDI, which stands for the Jobs and Economic Development Impact. Actually,
Faisal,
yes.
sorry to cut you off, but I will need to notify you that you have 2 to 3 minutes to wrap up this presentation.
Yes, I'm almost finished.
Thank you.
So these are the most famous tools to be used in the measuring socio-economic impact. But using these tools would require you to have a certain degree of accurate data, which we lack in Darfur. I will be speaking in the next slide about the challenges. One of them was the data. So the challenges that face this program was the market that lacks spare parts. There is a shortage in the inverters and the batteries. Also, there is a shortage in the skilled workers. So the output too is to develop the skilled workers. The third challenge, the safety. As we know, Darfur has been a conflict zone, so we have actually a main challenge to deliver or to transport the materials used for the power plant, or as a PV power plant, or wind turbines, or and so on. There is also a challenge of the accurate data. Actually, here in Sudan, all Sudan suffers from this problem. We don't have an accurate data to be used as to assess a specific area. And the fifth challenge is the non-existence of the DRA. The DRA stands for the Darfur Regional Authority. It was dissolved in 2016, and Darfur Regional Authority was responsible for cooperation and coordination among the 5 states. So it, I guess, in my opinion, has a huge contribution in this project, and this would affect the project. Actually, I will be moving to the recommendations based on previous projects. The first one is to encourage the private sector participation to allow for this sector to move on and to develop. The second one is to develop the technical knowledge, as I speak earlier about it. And the third one is to ensure safety in the site selection, because based on previous project, there were many parts of the systems that were actually being theft or stolen. So we need to make sure of the site selection. Actually, these are my article and my presentation, and these are the references that I used. Thank you for listening, and if you have a question, you can ask me.
Thank you, Faisal, for your presentation. It have been informative. And actually, the case of Darfur, which you presented, is actually getting the interest of so many people. Darfur in the west of Sudan is a good market for the solar energy. So thank you for your presentation. And with this, we will be ending the presentations part of today's meeting. So we will have the ceremony. I would like to invite all of you to attend the final ceremony of the Clean Energy for Africa Volunteers Program, where we will be having Tony Teo as a guest speaker. He's the founder and CEO of the Renewables in Africa, and the regular contributor to the BCC as a renewable energy and energy technology expert, and the holder of multiple certifications on renewable energy and climate change from different respected international organizations. So Tony will be our guest speaker, and he's a very good communicator as well as a very close friend with Dr. Mohammed Al-Haj, the founder of the Clean Energy for Africa. And Dr. Mohammed will be giving the opening remarks at the same time on the next Saturday. So see you again this weekend, and I will wish you a very good night. And Dr. Mohammed,
yeah,
yeah,
sorry. Before
yeah,
you
so
conclude, I
I
think we
will
had
hand it over.
some people who wanted to, yeah, okay.
Okay, so it's now handed over to Dr. Mohammed, whatever you would like to add. And yes, it's yours.
Thank you. Thank you everyone for attending, and thank you for Jennifer and Faisal for the informative presentations. I think we had some people who wanted to ask some questions. Abu Hassan, I saw your hand raised and then it was unraised again. So I'm gonna unmute you to ask a question. Ask to unmute. Okay, you just please unmute yourself, Abu Hassan, and you can ask your question.
Thank you for this time. I would like to ask a question regarding to presentation of Faisal from Sudan. I want to ask about the potential of solar energy in Darfur. How is that? Hello?
Yes. Actually, the potential of solar energy in Sudan in general is we have a very high radiation rate. So in all parts of Sudan and in Darfur specifically, so there is a great potential for solar energy in Darfur. Actually, the problem with Sudan in renewable energy is attributed to many reasons. Actually, I think the main reason of them was the funding. We lack the necessary fund for implementing such project, but we have really a good potential for solar energy in Darfur and in Sudan in general.
Okay, last question, then to pass this chance to another one. I heard about the project on Al-Fashir, I think about 5 megawatt, but the problem of that project is just running if only 3 megawatt. I think there is some problem, but do you hear about that? Could you tell me about something about this?
Well, actually, this is a separate topic from my topic. I have not much information about it. But I guess the project will be developed in the future for 100 megawatt, I guess, as I hear for now.
Is it off grid or on grid?
Actually, I guess it's off grid for the Darfur.
Al-Fashir is on grid. Al-Fashir plant is grid connected.
Grid
The
connected.
5 megawatt, yeah, the 5 megawatt plant that Faisal mentioned is grid connected. Yeah.
I think there is a plan to be hybrid generation there for wind farms and solar panels, PVs on Darfur. Maybe after the grid connected there reach Darfur, maybe there will be hybrid generation there. Maybe.
Actually, I didn't hear you, sorry.
Yeah, we're planning, by the way, to have like an project information like brief on this project specifically. We're just doing the data gathering at the moment, and hopefully, inshallah, we will publish it in our platform within the coming few weeks. So stay tuned for that.
Okay, thank you for your time.
Thank you, Abu Hassan. Thank you. We have Hussein. Hussein, just please unmute yourself, and then you can ask your question. Hussein, yeah, unmute. Okay, you can speak now.
Okay, assalamu alaikum everyone. My name is Hussein Shagar. I'm a founder of a private renewable energy company called Nasmo in Sudan. It's like almost 2 years ago company. I'm not an engineer, but I'm coming from medical background, but working in humanitarian sector for a long time. And I'm very interested, I'm fan in renewable energy. This is why I invested some money. And as Faisal mentioned, it's nice to see like young people who are fascinated with renewable energy in Sudan, which is, as everyone know, that it's a very potential and highly potential market. As what he said, that the private sector should be involved in this sector because the data in Sudan is very scarce, and most private sectors who are working in Sudan, they don't have like a clear vision. We have a different approach in our company, and this is why we want to check with such non-profit organization like Clean Energy for Africa, just to see how we could strengthen this field. Just first, regarding the presentation, I congratulate you, Jennifer. It was a very good presentation. And regarding the presentation of Faisal, just to mention, when you mentioned about the safety, it's known that renewable energy or the big projects in area of conflict, it's not like a feasible project because it could be demolished at any time. So usually it should be like a piloting. Regarding Al Fashir project, really I was trying to find more information because it was not clear how the bidding took place and all these things. And also regarding the budget, I think it's high budget for like 5 megawatt. But as you mentioned that regarding the security and the logistic thing, maybe this is increased the budget. I don't know. Engineer Muhammad Al-Haj and Zulfa may clarify more in this. But for this opportunity, I would like to participate. Unfortunately, nowadays I'm not in Sudan. But when I come back, I would like to be in touch with Faisal and you, Muhammad and Zulfa, if you have any proposals. I met Samia Faisal in Sudan, and I want to make like a partnership with one of the non-profit organization because there is a lot of potential from the African Development Bank or from the international bank for a lot of potential project and to sponsor some proposals. For me as a private sector, I cannot apply for such project, but for sure through, if we could create like a partnership or anything.
Definitely. That would be really amazing. We really look forward to that. I already sent you a private message. I really hope we can continue this chat afterwards through email. Maybe we can have another session. That will be very interesting. We're always looking for partnerships, whether it be with non-government organizations or private sector to develop and work on initiatives and projects aligned with our objectives of increasing awareness and improving the technical capacity of professionals and engineers in the renewable energy sector in Africa. So we really look forward to another conversation afterwards, Hussein, after this session, inshallah. Thank you very much. A few people asked about the slides. Inshallah, it will be sent to everyone along with the recording. I'm just going to put here in the chat the link as well to our newsletter. Please do subscribe. It's very important because we make all our announcements about our events in the newsletter. So so make sure to join to stay updated about our work. I actually have one question for Jennifer. Jennifer, you mentioned in your presentation an interesting application of solar in Kenya, which is the micro solar systems. I think you mentioned something about using mobile payments for solar home systems or something like this. Or in general, small scale solar home systems. If you can just tell us more about the main reasons why these systems work very well in Kenya and are affordable. Like what exactly has the government done? Is it reducing, for example, or removing all import taxes on these systems? Or what are the really key things that the government has done that makes these systems very affordable in Kenya specifically? If you can just tell us more on this topic.
Thank you, Mohammed, for your question. And the reason why there is high solar home systems in most parts of the country is because they are cheap, and this is because the government has removed most of the solar energy equipments that are imported. They are duty-free, and no VAT is paid for such equipments. So that's why it is widely used in most of the rural areas.
Okay, thank you. Thank you very much for elaborating on that, Jennifer. Zulfa, I think we can conclude now. I don't know if you have any final remarks before we close the session.
I'd like to just to thank, yeah, hi guys. I'd like to just thank Jennifer and Faisal for their presentations. I mean, we really enjoyed, I guess. And it's a pity that Matthews couldn't, click with the internet for some reason. But maybe perhaps on the coming ceremony, of the final ceremony, maybe you could just give us a quick, if he's available, maybe at that time, he could just give us the presentation, a brief presentation first, and just to know a little bit more about Malawi for the audience. And just reminding Jennifer, when when we spoke about Kenya, he said like right now we've got 70% electricity rate access in Kenya. That's quite high, I guess. I mean, that's interesting. And the target is to have it 100% by 2022. I mean, that's quite amazing, actually. So, I mean, these figures are, I'm not sure if you compare to the other countries within Africa, we thought like that's definitely probably above average, what we have in Africa. I mean, definitely in Sudan, I guess. And my question is regarding you mentioned the biogas systems. We've got like 20,000 biogas systems right now in Kenya as of 2019. And I was just wondering what sort of, the power conservation of that within Kenya.
Sorry, I did not get your question about the biogas systems.
Yeah, biogas systems, you said there are 20,000 biogas systems running right now in Kenya. So what sort of like power contribution? I mean,
most of these systems are personally owned, like in rural areas, and you find that few of them are built in institutional centers such as schools, and yeah. So there is no energy from the biogas centers that is grid connected.
Okay.
Yeah.
Okay. Because 20,000 is quite a lot, I guess. I mean, 20,000 biogas systems up and running in Kenya. And as you mentioned, the 70% electricity access rate, that's quite high as well. If you'd like to comment about that.
Sorry, I didn't get your question well.
I mean, we've got a high electricity access rate in Kenya, is it right? 70%,
yes,
I guess.
75%, 75%.
Yeah. And I guess that's quite high. I mean, if you compare it to other African countries.
Yes. And most of this is because in Kenya, there's quite huge potential for renewable energy, because currently geothermal contributes the highest energy, followed by hydro, and then commissioning of the Electrification wind turbine added this.
It's the one in most of it, is it?
Yeah, yeah.
Exactly. It was a bit controversial regarding the wind power at most of it area. But I don't know how's the situation right now. But thanks a lot anyways for the, so it's a very, very nice presentation by you and Faisal, and really enjoyed it here, and guest audience as well. So thanks a lot, guys.
Thank you, Musaddaq. I think we have Dr. Hazir. Dr. Hazir, you can unmute yourself.
Yes. Yeah. Thank you, everyone. I just want to add what Jennifer said about the biogas, replying to that question. I think the 20,000 biogas system, most of them are for household, so small scale. So they use it for cooking, and they use it for fertilizer for agriculture, like for home gardening. But yes, as Jennifer said, there is no contribution for production of electricity. So you can find a bigger system than household. Households mostly between 4 to 8 cubic meter, but you can find like for slaughterhouses, which is big, but they also use it. Even they compress the gas, they use it also for like community responsibility for the houses near the house, the slaughterhouse, something like that. So there is no big plans for biogas. Thank you.
Thank you.
Okay,
Thanks a lot, Dr.
Thanks a lot, Dr. Hazim, for the clarification. Thanks a lot.
Thank you. I think we have to conclude now. It's almost an hour and a half. So thank you everyone for attending. Thank you to our volunteers for their presentations. I think we have a graduation ceremony for the volunteers. It will be this coming Saturday at the same time, 6 p.m. Sudan time. So please do join us. We'll be sending the link in the newsletter already sent, and we'll announce it again on our Facebook page and our LinkedIn page as well. So please follow that. And in our graduation ceremony this coming week, hopefully we'll be able to listen to the presentation of Matthews, who was unable to present today, unfortunately, due to some technical issues. So hopefully he'll be able to make his presentation on renewable energy potential in Malawi. And we'll also be having a guest speaker for that session on Saturday. So we highly encourage everyone to attend. So thank you everyone for tuning in, and have a good night. Bye-bye everyone.